Hi. In this session, we are going to talk about statistical significance and hypothesis testing. To understand what statistical significance is, we need to start with an example. If we have a research question that's trying to answer if protein X concentration is associated with certain disease, we will start by collecting data, and the data collected may look something like the one shown here. You can easily say here that protein X concentration has a significantly increased level in diseased patient compared to healthy patient. It has a statistical significant increase. But actually, in real life scenarios, the data collected would not would more likely look like the one shown here and the one shown here. If I ask you, can you say for sure a protein X concentration is statistically significant increased in diseased compared to healthy patients, you would not be able to answer that for sure. And here comes the rule of hypothesis testing. It's used to determine if a population are statistically different from one another. And there are four types of these tests that are high yield for the USMLEs. And all you need to know is when to use each of these tests. And you don't need to know how these tests are being performed. You only need to know what kinds of data these tests are used on and when to use each and single one of them. So first we have the t-test. The t-test is used when comparing means of two groups. As we mentioned, means. It means that we are working on a numerical data and we are trying to compare between two groups this numerical data. An example of this would be the mean blood pressure difference between males and females. Okay. And we have two types of t-test, an independent t-test and a paired t-test. And they are differentiated based on the sample we are working on. In independent t-test, we compare different samples. So as we mentioned before, the mean blood pressure difference between a group of males and a group of females. While in paired t-test, we compare the same group, but in a different period of time, maybe before and after a treatment, maybe before and after an intervention. An example of that would be the mean random blood sugar level between a single population, the same population pre and post treatment. The next test is ANOVA testing. ANOVA testing is exactly like the t-test, but it compares three or more groups, and it also deals with mean values. It deals with numerical data. The next one is chi-square testing, and this one is actually different because it does not work on means. It does not use numerical data. It only works on categorical data. We divide people into two categories. An example of that would be the percentage of diabetes mellitus cases in three ethnic groups. The percentage of the presence or absence of diabetes mellitus. We are not talking about numbers. We are not talking about random blood sugar level. We are talking about only about the presence or absence of a disease in a group, in two groups or more than two groups. Okay. You need to differentiate it from the Fisher's exact test because it's exactly the same and has the same usage, but the only difference is the Fisher's exact test works on a smaller sample. Like if we are comparing 20 males and 20 females for the presence or absence of diabetes. This diagram sums this up. If we have numerical data that we are trying to compare, we may use the t-test or ANOVA testing, depending on the number of groups. And if we have categorical data that we are trying to compare, we may use the chi-square test or the Fisher's exact test, depending on the sample size. You will find uh, this lecture information on first aid, page 266. And let's finish with a question to make sure that you understood. If a researcher is investigating whether there is an association between smoking status and the presence of lung cancer, the presence or absence of lung cancer in 500 patients, what statistical test should be used? We are comparing categorical data. There is no numbers here. The presence or absence of lung cancer in a large sample of 500 patients. What test should we use? Yes, the chi-square testing. And thank you.